Hello, everyone. Got another topic here today. So, this is something that's not going to be on the tests, but we are going to have a lab assignment for it. It's something that's strange, but that people going into healthcare professions should be aware of the apothecary system. You may know apothecary is old timey medicine, well, the old timey version of, I guess, what we would call a pharmacist today. And so, the apothecary system is an ancient system for measuring drug dosages, and it's not something you should use in the modern times, but sometimes you may be forced to. You may get some script or something that's written in the apothecary system or some old record, something like that. So it's just something you should be aware of. Not going to be on a test, but we are going to have a lab on it. Um, so there's a few quirks being an old system. Is that we're always supposed to round to the nearest quarter of an inch, so 6 1/4, 6 1/2, 6 3/4. So when you're using the apothecary or reading it, you'll get mixed numbers, so number and a fraction instead of 6.25. Used to be in Roman numerals, but we're not going back that far. And then the next part is, and there's an argument that this is more efficient, it's just not how we do things this day, is they flipped the orders of the unit and the number. So instead of dr as a unit, we're going to introduce drams. But so instead of saying 4 drams, the way we'd expect for something like 4 grams, if we're using the metric system, we would say 4 grams, 4G. For the apothecary system, you write it the other way around, so drams 4 instead of 4 drams. Do, do, do. And so these kind of old time units are related to just, these days we have scientific ways of defining most of our units. This time is just what did people have. So one unit is the grain, likened similar to the size of a grain of wheat, so pretty darn small. So you take pinches of a powder, measure it in how many grains did you take out, something like that. And then so as far as our dosages, we've got that it takes about 15 and a half grains to make 1 gram, or that a grain is 65 milligrams. So I've taken that slide onto a little whiteboard here. So and just written it out the way we would as equality. So 1 gram, excuse me, is equal to 15 and a half grains, where you can see, thanks to the apothecary system, I've written grains first and then the 15 and a half value. Um, Alternatively, we could say 65 milligrams is 1 grain, or grain 1. Once again, flip that order around. And if we were to do the good old metric conversion, which love metric, easy conversions, we would just want to move the decimal back 1, 2, 3 places. We could also figure out that 1 grain is 0.065 grams. So, aside from that, it's not the peculiarities that we've done. It's not all that much new. We just can use the same technique, unit fraction technique, to do conversions in the apothecary system, just with some new measurements. So, if we want to convert 6 grains into milligrams, well, we'd want to find an equation that compares milligrams to grains, if we have one, and looks like we do. And we want to set up our unit fraction. So grains 6, you can put it over 1. That helps some people. Then they know they just need to multiply across. And we have that 65 milligrams is equal to 1 grain. We want our answer in milligrams, so we should put that on top. And grains 1, so that's what we're getting rid of. We should put that on the bottom. So we wind up with 6 times 65 divided by 1 times 1, which would just give us a over 1 over here that then we can get rid of for our final answer. And so 6 times 65, plug it into a calculator, we get 390 milligrams. So 6 grains is 390 milligrams. Then we could also look at converting it the other way. Say we needed to convert 150 milligrams to grains. So 150 milligrams, we can go ahead and stick it over 1 if that helps us with the math. And we want to use the same ratio in this case. Grams 1 is equal to 65 milligrams will help us convert between milligrams and grains. In this case, we want grains in our answer, so we better put that one on top. 65 milligrams on the bottom is what we want to get rid of. And we wind up with grains of 150 divided by 65, which if we plug it into a calculator, we get 2.3076 ... more digits coming. And so here's where a peculiarity of the system comes in. We have to round to the nearest quarter of an inch. In this case, it's going to round to 2¼ inch. And we could test this. I'm actually going to pop back to the slides here. But the way to test it would be to compare it with both 2.25, which is the same as 2¼ and 2.5, which is 2½. If you were to subtract it from both and compare which number was bigger, then you could figure out which was closest. But at 2.30, 2.3031 looks a lot closer to 25 than it is to 50, is the simple way of thinking about it. So, indeed, we're going to want to round it to 2¼ like they got right here. Then we got some new units for fluids as well. Well, one's our usual unit that has stood the test of time. So ounces is the same in apothecary system or modern imperial system, whatever we want to call it. Only difference being is if it's in the apothecary system, normally we'd write 1 ounce, but if we happen to be working in the apothecary system for some reason, then we would write it as OZ1. Just once again, flip that order. But then reminder about ounces is that 1 ounce is about 1/8 of a cup, or 1/8 C, or 2 tablespoons, TBSP. Some of the slides also just use big T for tablespoons, so that may be sometimes an abbreviation. I prefer this one being less ambiguous. And then we have that a dram, now an apothecary unit, is 1/8 of an ounce. So DR1 is equal to 1/8 of an ounce, or that a minim is 1/60th of a dram. So minim, M-I-N, is 1/60th of a dram. And we could actually flip that around real quick. So one thing when you have an equality is you can just, if you do the same thing to both sides, when you do the same operation to both sides, so operations like addition and subtraction, multiplication, division, you can do it to the both sides and still maintain an equality. So if we multiply both sides here by 60, 1 times 60 gives us 60, 1/60 times 60 gives us 1. We can flip this ratio, get that 60 minims is 1 dram. So that's an alternative version of this ratio. We could do the same thing with the drams up here. We could say multiply both sides by 8 and find that 8 drams is equal to 1 ounce. Alright, but let's do some examples here. So say we want to go from ounces to drams, and I solved this before I had written this new formula, but it works either way. We can use either of these equations and get to the right answer. So ounces for, we want to get drams. So we should take those 4 ounces. I've written it the opposite way around, assuming we're working in the apothecary system. And we can stick it over 1 if that helps us. Don't have to. And then we can use this equation, dram 1, put that on top because it's the unit we want. It's equal to 1/8 ounces, put that on the bottom. Since that's what we want to get rid of, we wind up with 4 drams divided by 1/8. And if you plug that into a calculator, it should sort it out for you. But you can also remember an old rule that when you're dividing by a fraction, like 1/8, then it's the same as multiplying by the inverse, the flipped around version of that fraction. So 4 times 8 over 1, flipped around, 1/8. And ultimately we get our answer. I went and squished my writing a little bit there, but to make it clear, drams, 32 drams, or drams 32. Then another example, the tablespoons. We want to convert 1 tablespoons to drams. And actually, we don't have a direct link here between tablespoons and drams. But what we do have is tablespoons to ounces, and then we have ounces and drams connected to each other. So we can do a two-step conversion here. So first, let's get from tablespoons to ounces. So 1 tablespoon times 1 ounce for every 2 tablespoons will give us, so using this 1 ounce over here is equal to this 2 tablespoons over there is our equation. Put the ounces on top, the tablespoons on the bottom, and we find that 1 tablespoon is 1/2 of an ounce. So we got from tablespoons to ounces. Now we need to get all the way to drams. So take our equation that compares drams and ounces. Drams 1 is equal to 1/8 ounces. We get 1/2 ounce times, put drams 1 on top, times 1/8 ounce on the bottom, what we want to get rid of. So we'd wind up with 1 times 1 on the top, giving us 1. 2 times 1/8 on the bottom, giving us 2/8. You could just plug it into the calculator again, but 2/8 is the same as 1/4, and doing the same flip the bottom fraction round trip, we get a final answer of 4 drams. And actually, we can add that to our list of known ratios as we want that 1 tablespoon is just equal to 4 drams. You don't have to memorize any of these conversions. They'll be provided, or you'll be able to look them up for the lab. But just to help us out with these problems. And one more example. Let's say we have 45 minims. So minims here is the equivalent of a drop. So imagine taking a little pipette and doing it drop by drop. And so that's 1/60th of a dram is the conversion we know. We can flip that around like I did here and say that 60 minims is 1 dram. And so if we have 45 minims, let's use this one right here. That's going to make the math a little neater. So put drams on top, the 1 dram on top, which is what we want. Put the 60 minims on the bottom, what we want to get rid of. We get drams of 45 over 60. And since we want to come up with a fraction, there may be a way you can trick your calculator, not trick, but format your calculator to give you an output fraction. If not, you would just have to recognize that 0.75 is the same value as 3/4. So once again, in the apothecary system, we want to give our answer in quarters, and therefore our final answer should be that 45 minims is 3/4 of a dram. Alright, so yeah, there'll be a little lab on this. Weird units, but still good, more good unit fraction practice. Hope this helps.